Good afternoon, everyone. Thank you for tuning in once again for our virtual tour of outer space. My name is Josh. I'm part of the Morrison Planetarium team at the California Academy of Sciences, and we are delighted to be joining you at your home or wherever you might be, hopefully around home, checking out some of the really cool stuff that's in our solar system today. So if you have an idea about some place in the solar system you would like to visit, please let us know in the chat. Today we are flying around in our OpenSpace software, which is a kind of planetarium software, exactly what you're seeing on the side of the screen. But this one is extra cool because it has the amazing feature of being downloadable by you at your home, where you can fly exactly like I'm going to do for free. You can check it out. Let us know what you think. If any of you have downloaded OpenSpace and played around with it, put it in the chat. And also, for all of our viewers, we would love to know where you are tuning in from, and if you have any guesses about what this lumpy gray mystery object might be. Some of you look like you may have watched our stream before. This is something we have visited in the past, so if you know what it is, put that right there in the chat. Okay, so when we fly around in open space, I'm using my computer to do so. You can see my mouse hovering right there. We are checking out something that is a little bit tough to identify. What if I told you this used to be a planet long time ago? It was discovered and was made the newest planet of our solar system that had been discovered by human beings. It was a pretty exciting time. Now, a little while later, people eventually uncovered the fact that this wasn't alone in its part of the solar system. There were actually many other objects hanging around it. Now, when those objects were discovered, first there was one, then another, then another, then another, then another. And when you finally added them all up, there were tons of these things. So they decided that this thing was sharing its environment with too many other objects, and it probably shouldn't be considered a planet. Which object is that? You might be thinking Pluto, because the exact same story applies to Pluto, but I've been intentionally vague around the dates. This is actually Ceres. Ceres was discovered in the year 1800, I think 1801 technically. But when we found Ceres, it was part of the asteroid belt, still is today, and is considered today an asteroid. And it's considered a dwarf planet. I think a little bit like Australia, it's more than one thing. Yeah, Australia is an island, but it's also a continent. Ceres is a dwarf planet and also an asteroid. Now, when you're looking at the surface of Ceres, you can see some pretty cool stuff. Number one, I think those whitish dots right down there on the surface are probably water-soluble material that's been stuck on the surface. That's pretty cool. We didn't know you could have flowing water on an object like this. And it might not be flowing today, but it's pretty good evidence that water was moving there in the past. That is absolutely unexpected on a small object like this, much, much smaller than Earth's moon. Now, this was an object suggested to me by my wife. I am happy to take suggestions. She just managed to do it before the show even started. If there's something in the solar system you want to see, please let us know in the comments. Suggestions from the audience make for the most exciting tour for me, because even I don't know where we're going next. Okay, so after we visited that, I had another idea for kind of a cool thing to check out in space, but not something in our solar system. In fact, this is something I can't even fly you to. It's more of an interesting spot in the sky around us. Now, these blue dots we often show in our presentations at the very end. We decided to give you that little sneak peek earlier on. All these dots are showing you places where human beings have discovered that there is a planet around another star. We call them extrasolar, or exoplanets for short, and there are tons of them. Now, when we're looking around, you might notice some places have more exoplanets recorded in that unique spot than others. That's not random. When we look around here, those are places where we've discovered a planet that tells us something about the distribution of stars, or at least stars we can easily see. But there's one spot you may have noticed that is a little bit standout, even amongst those. Right there, we have a huge cluster of objects. This is what's called the Kepler field of view. Now, Kepler, the space telescope, was an exoplanet hunter. For about 4 years, it stared at this patch of sky and uncovered every star that it could that changed brightness. Some of those were because of sunspots. Some of them were because of many different factors, even orbiting another star. But some of them were teased out to eventually reveal that there were planets traveling around that star. And sometimes those planets passed between us and their star, blocking some of the light. Now, when we look at that part of the sky, keep your eyes on it because I am flying us away from our sun. Right now, I think we're about 2 light years away from our sun. And as we zoom back more and more, you can actually start to see something very cool from Kepler. This isn't just a 2D patch of sky, it's a 3D cone of the universe. Now, that is where we have found an absolutely huge amount of planets around other stars. You can see it hanging off to the side of my screen right here, that incredibly well-populated region with all of those solar systems. Now, they found some very distant solar systems. They found some very close solar systems. They just found a ton of solar systems. There are more solar systems than you could shake a stick at. But amongst all those solar systems, there is still only one spot that we know hosts life, and that is our very own planet Earth. But we are not conclusively sure that life only exists on planet Earth. It's just the only spot where we know life exists. Ooh, we've got some requests for features on Mars from Kim and from Mary. I think that sounds like a great idea. Let's go check it out. Okay, so heading out to Mars. When we get to the surface of Mars, you have a chance to see some really cool features. Amongst them, some of the biggest mountains in the solar system, the widest, deepest canyon, I believe. And I think something that's often overlooked as a really cool feature of Mars, it's ice caps. You can see little ice caps hanging out in the extreme northern and southern regions of Mars. That's where we do see frozen material. Now, you can see some of the megavolcanoes from way up here. Looking down to the surface, I see 1, 2, 3, 4. One is much bigger than the others. There's 2, 3, and 4. These are parts of the Tharsis Plain. Now, looking around here, you can see calderas on some of these volcanoes. That's the part in the very top that in cartoons is always full of bubbling lava. But down here, you can see no bubbling lava on Olympus Mons. That's the biggest of these volcanoes. If we want to see nice details, we got to back up, move in at just the right angle, and drop ourselves down to the surface. One of the really cool things about OpenSpace, and again, something you can do at home, is checking out the surface in 3 dimensions. You can actually see the height of Olympus Mons compared to the regions around it. And if we give it enough time, and my internet's fast enough, we actually get to see some of the high-resolution data come in. Now, Olympus Mons is really tall. We often don't get a great perspective on that when we're just looking down at the surface, but check this out. That's not an exaggeration of its height. It actually pulls off the surface of Mars that much, so we can actually see this incredible peak juts out from the very top of Mars's atmosphere, meaning that if you were someone born on Mars, we'd be calling you a Martian, and you hiked up to the very top of Olympus Mons, even if you'd never ever been in a rocket ship, by some definitions, you could be considered an astronaut because you'd traveled to space. You'd gone above the atmosphere of a planet, and you never blasted off to do it. That is a pretty cool technical distinction. And as Futurama says, technically correct is the best kind of correct. So looking around here, you can see a bunch of crumbly rocks, those same very big volcanoes. And of course, that other feature par excellence is Valles Marineris. Now, Mariner Valley was discovered by the Mariner 4 spacecraft as it whizzed past, gave us a really cool view of the Martian surface. Some science fiction stories like to imagine that human beings will one day live on the sides of these canyons, like many indigenous folks have here in the United States, cutting into the walls of the canyon to make sheltered places. That's a great way to do it. Living in the wall of something gives you a ton of space automatically. Nature has done the hard work of cutting the rock open, so you can dig into the side and make shelters. There's ideas for similar structures on the surface of the moon, but they don't have canyons like this on the moon. In fact, nowhere else in the solar system has a canyon like this. You can see it is so wide and so deep, we actually get the glow of the atmosphere pooling at the bottom of Valles Marineris. That is one of the coolest things to see. So I could spend a whole show talking about Mars, and have in the past. But if you have other suggestions about places you would like to go or other things you'd like to see, just let me know. I will happily take us on our way. Corey's making fun of me, asking what is my favorite moon this week. My favorite moon changes an awful lot. Well, let's see. Where would be a cool moon to visit? I would say let's head out to Triton. Now, Triton is at the very outer edge of our solar system, and if I recall, Triton has some issues on my computer, but it's just so cool and so weird that it's worth checking out anyway. Now, I can't bring you a high-resolution map of Triton, but if you look online, you can see one. It is a very cool thing to check out. If we show the trails, though, you can immediately see something kind of interesting about Triton. Let me see if I can put on the trails. Here we go. So Triton goes well above and well below the plane of Neptune's transit through the solar system. Neptune's traveling along around the sun. You can see the sun way over there. And as it's traveling along, Triton goes significantly above and below the plane of the planet. Now, that's not uncommon. We see that around plenty of other spots. But what is kind of weird is the direction it's traveling. Turns out all the other moons of Neptune, travel the other direction. They don't go left to right like this is doing from our perspective. They would go right to left, clockwise instead of counterclockwise, or counterclockwise instead of clockwise. When we look at them in comparison to Triton, though, it becomes pretty obvious that Triton was not native to the Neptunian system. We think Triton actually originated elsewhere in our solar system and got snatched a long time ago. And we base this on the fact that when you look at Triton, you can see light regions and dark regions. You can see a lot of smoothness on the surface that probably indicates a degree of activity. And all of those things are stuff it has in common with Pluto. Now, Pluto has a huge amount of activity on the surface. It's got light regions, it's got dark regions. It's a very interesting, complex world, to be sure. And the more we look at Pluto, the more we try and understand it, the more similarities it seems to have with Pluto. Now, Triton and Pluto very well could be kind of long-lost siblings. Pluto's looking pretty exciting right now. It's tiling in. There we go. Pluto is not actually see-through. That's just what my computer is doing. But you can see something very cool that is not a challenge of Pluto on my computer right now. Check out this blue line. When we saw the orbit of Neptune, it went right to the center of Neptune. When we see the orbit of Pluto, it looks like it missed Pluto. What's going on here? Well, that line is actually showing us the middle of the Pluto-Charon system. The middle of the Pluto-Charon system is right there. That is the point that Pluto orbits. That's the point that Charon orbits. They're both going around each other. You could imagine if you put them both on a seesaw, this is where the fulcrum, the balance point of the seesaw would be, very close to Pluto, because Pluto is a lot bigger, but not that much bigger than Charon. So that's a really cool thing that is not my computer freaking out. Everything else in this image is part of my computer freaking out. But in looking at the Pluto system and Triton, we can learn that these little tiny Pluto-like objects are pretty common in our solar system at one point in the past. In fact, based on some studies, some analysis of the objects that remain compared to how many there might have been, we think there may have been about 2,000 Pluto-like objects in our solar system in the ancient past. Where are they? Well, I have 3 possible scenarios for them. Some of them probably got flung out of our solar system. They coasted too close to a big planet like Jupiter or Saturn and got a gravitational slingshot out. It's also possible that they crashed into massive objects like the Sun or Jupiter or Saturn. Now, with those possibilities, none of them seem super great. There's a lot of potential attrition where things could have been lost over time. But generally, they're either still here, they got flung out, or they got absorbed by a larger object. So our solar system is a dynamic and interesting place. There's always a lot going on. When I think about the solar system I learned about in school, it's static. It doesn't change a whole lot. When I look at the placemat you get at a restaurant that has those planets on it, it doesn't change day by day, month by month, or year by year. Granted, decade by decade, we might update the count of planets or the count of moons. But things are a lot more dynamic than that. They're always changing. Objects drift in, they drift out. We find objects coming in from other solar systems. We've now found 2 comets that probably originated around another star. And on the scale of many thousands, tens of thousands, hundreds of thousands of years, we might actually see the planets wander a little bit, move around. Over millions or billions of years, we can actually see bigger changes occur. We think Jupiter has migrated significantly in its orbit over time, meaning it's traveled farther and closer from the sun, and over that time has probably had a huge amount of influence on the rest of the solar system. Right between Mars, that's the orbit right here, and Jupiter right here is our friend we visited originally, Ceres. Now, Ceres is part of a region called the asteroid belt. Looks like Trisha wants to see the Kuiper belt. We'll get there in a minute. But this asteroid belt is pretty densely populated with tiny fragments of rock. Now, not like we see in Star Wars, which is one of my favorites, or even Star Trek. The rocks aren't a super dense field of gravel. There's a lot of them, sure, but standing on any one of them, you'd never see the others. They're just too small and too far away. But if you were hanging out on Jupiter, you would see Mars way over there in the distance, and this asteroid field would be located between you, even if you couldn't see it. Now, we think Jupiter over time has thinned out the asteroid field. It's bumped into those objects and sent them flying, kind of like those Plutos in the ancient past. Those flying objects have careened through our solar system and may have left some trauma behind on the inner planets, specifically our rocky planets, things like Mercury, Venus, Earth, and Mars, and our moon, the moon. We call that the heavy bombardment, and it was probably a pretty exciting point in the solar system's history when all these objects came flying through and smashed into stuff. Now, similar to the asteroid belt, the Kuiper belt is a little tough for me to show you. When I turn it on, my computer gets very unhappy. But it is an asset that exists inside OpenSpace. So if you want to check it out, download the newest version of OpenSpace and fly to the asteroids. You can see some really cool stuff. Now, our asteroids and Kuiper belt are two of these dense fields of objects that hang out in our solar system. Similarly, for a long time, we thought we had planets around our sun, and those are the only planets that exist. Then we began finding those exoplanets, the planets around other stars. Well, today, our telescopes are getting powerful enough that we're actually finding dust clouds, even asteroid belt and Kuiper belt analogs around other stars. This is a really exciting moment to be paying attention to astronomy, because things that we just never thought would be possible are becoming possible. Taking pictures of objects around these other stars is something tremendously exciting. Now, when we talk about a picture, often it's a brightish dot. If you check out our cosmic conversation from last week, we spent a little bit of time looking at some of these. That was our night life presentation. We saw some of these baby solar systems, baby exoplanets in these early moments of formation. It was a really cool thing to see. Now, a baby solar system might sound kind of cute, kind of silly, different, but all solar systems are undergoing that process of change. We are all evolving over time. Objects are moving, objects form, objects disappear. It's the nature of things to change, and solar systems are no exception. Okay, let's see if we have other ideas of places to visit. One that is frequently requested, and I'm going to guess somebody out there might be interested in seeing, is our next planet out from the sun. That is Saturn. Saturn is absolutely beautiful. Those iconic features of the rings, for sure, are something to check out. In fact, right now is about the best time of year for viewing Saturn in the night sky. If you have access to binoculars or a telescope, go outside and check out Jupiter and Saturn. They were close to the moon a couple days ago, which means the moon's a bit past them. And now that I think about it, it also probably means we're at very close to a full moon. So maybe it's not ideal. But if you want to hear a real expert talk about cool stuff to see in the night sky, you should tune in tomorrow at 1:30, where Bing Kwok will be telling us about cool things to check out in our night sky in our regularly scheduled night sky update. And I see we had at least one viewer who's almost 4 years old. Nice to hear from you, Ren. If you want to check out our early morning programming on Tuesdays, Mary Holt's going to tell you about some of the cool stuff you can see on the moon, or how you can learn from your shadow here on planet Earth. Okay, so I talked about the heavy bombardment, and I think that is a fascinating subject. Let's head in to the inner part of our solar system and see some of the scars left behind by the heavy bombardment. Now, I'm going to countermand myself since we couldn't see it before and say to Corey, this is in fact going to be my favorite moon this week. Our moon. It's my favorite moon a lot of the time. Our moon appears to be afflicted by the same disease as Pluto, though, and has become see-through. Let's see if we can get it to fix. Oh, almost. There we go. Getting closer. Down towards the surface, you can see some of those cool craters coming in. Now, when we look at these craters, someone asked a couple shows ago, how many craters are on the moon? Oh boy, that depends on what you call a crater. There's big craters, there's little craters. There are lots of tiny craters. But when you start looking at the really big craters, we can see the 10 largest all probably date back to around this heavy bombardment. And that includes some absolutely gigantic ones. Like these seas up here probably originated when something big struck the moon and lava pooled, filling up that crater. That's really intense. Kind of an amazing thing to think about, that much material changing very quickly. When these things struck, our moon probably glowed from the hot material hardening on the surface. That would have been something to see. Unfortunately, nobody on Earth was around to check it out. This probably happened in the first billion years of the solar system. And if there was life on Earth, which I understand is a possibility, but certainly not life with complex eyeballs and telescopes, then no one would have been around to appreciate it. So our moon is an interesting and volatile place in its ancient past and is an exciting world for visiting or planning to visit today. We got a request to see Venus without its protective outer layer of clouds. I think that sounds like a cool idea. It's Venus not as human eyes could see. Venus is very bright in our sky when it's visible because of this cloud layer bouncing light from the sun, and it's a dynamic cloud layer. It's always changing, and observing it can be a really tough thing to do. So for human beings, we often rely on a photo that was taken many years ago to show us what the clouds look like. In truth, I can guarantee you one thing. The clouds do not look like this at this exact moment. Why is that? Because clouds are always changing. I can tell you this is probably very close to how the clouds would look because the clouds on Venus have a couple different bands and not quite the dramatic dynamic effects of the clouds of Jupiter and that great red spot. So looking around here, we had a request to see Venus without its protective cloudy layer. Let's check that out here. Now you can see some of this weird, ripply, changing rock. One of the things I love about flying in planetarium software is I do a lot of time flying around in planetarium software. It's kind of my job. But I always find new things. There's always cool new things to see that I might never have noticed before. I've never really paid attention to this wiggly rock on this side of Venus that you can only see when you turn the atmosphere off. That's really cool. Maybe after the show, I'm going to spend some time trying to figure out what causes all this wiggly stuff. And we'll have more information for next week. But without the cloudy layer, you can see some of the craters of Venus. They do exist, but more frequent than craters, I think, are these volcanic features. There was a study pointed out recently that advocated that Venus might still have some active volcanoes, some activity on the surface, which is not what people would have guessed. A lot of people would assume that Venus is an inactive or dead world, and any surface activity would be caused by its dynamic atmosphere. But there's a possibility for active geology, volcanoes and their kin on the surface of Venus, and that is really cool. Our solar system has so many exciting and interesting things. It is always a joy to see that there is room for discovery and more innovation, more information coming to light. Ooh, Trisha wants to know, does Venus have any moons? When we look at Venus, let's zoom back in. I can turn on all of our lines that show us where planets are hanging out. Venus has a line right here. No moon lines around it. Let's go check out its next door neighbor, Mercury. Same deal. No moons around Mercury. When we head out to Earth, it has, of course, our one moon. And when we head to Mars, we can actually see two moons. Mars has Phobos and Deimos. Now, sometimes called Phobos and Deimos. I've been corrected by people who speak better Greek than I do. Phobos and Deimos are probably a little closer to how we should be saying it. Okay, but when we get out here, I can show you the orbits of Phobos and the orbit of Deimos right there. Now, that's kind of cool to be able to see those two moons. It means that Mars by itself has more than half of the moons in the entire inner solar system, but it still only has two. Earth has a third of all the moons in the inner solar system, but it only has one. And those three moons are the only moons we have within the asteroid belt. Now, there are some objects that are not planets that have moon-like objects going around them, some asteroids, I believe. That's just anything that has a smaller thing going around it we call a moon right now, which is a pretty cool thing to think about. But when you zoom out to here, you can immediately see that objects like Jupiter or Saturn are going to immediately come to the front when we're talking about number of moons. Now, it's possible this is just a function of mass. But if it were just a function of mass, then I would expect Venus and Earth to have the exact same amount of moons because we're almost the exact same mass. When we look at Jupiter, you can see its major moons right here, the 4 Galileans. What I'm not showing you are the jillions of minor moons traveling around Jupiter. When we talk about Jupiter and Saturn, they have way more than half the moons of the solar system, with around 70 each. I'm going to guess that they got 150 moons together. That's a whole bunch, and way more than we have on the rest of the planets combined. In fact, I think either one of them would outweigh the rest of the planets combined, excluding the other. Okay, so moons in our solar system, controversial topic because it is intrinsically related to that most controversial of questions. What makes some things planets and other things not? We talked about this, I think, last week, about you can only call something a planet if it's going around our sun. Otherwise, it's called an exoplanet, and that is a weird definition. We don't seem to be that touchy about moons, though. We're happy to call a small object orbiting an asteroid a moon. We're happy to say that we are looking for exomoons, which to me would imply that exoplanets are planets, but that's a semantics argument we don't need to get into. In any case, I think we've spent a wonderful 27 minutes flying around our solar system. If any of you have questions that you didn't feel like you could ask right when I was talking about something, post it in the comments. We would be happy to come back to some of these questions later. If you thought of something really exciting and you want me to fly there, save it for next week. We're going to be doing this broadcast again. You can tune in on Tuesdays to see our early morning stuff. You can tune in tomorrow on Thursday to see our guide to the night sky. And this week, Cosmic Conversations, we have an expert, Seth Shostak from the SETI Institute, tuning in, and we are going to be talking to him about humanity's search for life beyond planet Earth. And next week, one of my absolute favorite astronomers of all time, Dr. Adrian Kuhl from San Francisco State and Astronomers for Planet Earth, will be tuning in for our Cosmic Conversations, and I'm very excited for that one. Thank you all for joining us, no matter where you're tuning in from. We really appreciate you staying tuned and participating with us in these awesome programs. If you have any questions or comments, please let us know. And on behalf of myself and the Morrison Planetarium, thanks for joining. Have a great rest of your day.